Okay, everyone, welcome back to chemistry. This is actually my third take on this little video because I keep screwing it up, so I'm going to try to do it correctly this time. Before you leave tonight or today, who says it's tonight? Well, actually, it's all right. Never mind. Before you leave, I want you to understand these terms: atoms, elements, molecules, compounds, and network solids. Okay, you will have a good gut understanding of all of these before you leave. Well, first of all, we're going to talk about. I pick penny, and this is a penny before 1972. So I can say pretty conclusively that it's basically made of all copper, right? It is 100% copper for our purposes. There's a little bit of other elements in there, but I don't care right now. All copper. Well, what do you know about it? Take a penny, and if you could, break that penny down to the smallest individual piece. Like if you had a knife and you could actually chop this penny up, or have like a little hole puncher and take little hole punches out, but the smallest hole puncher in the world. And that single hole punch could take out one piece, and that one piece would still be a part of the penny, but it would be the smallest you could get. That thing is what we would call an atom. All right. Um, so it's not just any atom, it's what we would call an atom of copper. All right. And there's lots of different types of atoms that are out there. Okay, great. Copper atom. What do you think a copper atom looks like? Well, people say, oh, it's a circle. And I say, well, try again. Think about it in three dimensions. They say, oh, it's a sphere. And that's a really great analogy for an atom. Atoms are spheres, and I'll show you a picture of what they look like in a minute. In fact, I'm going to show you a picture of what they look like right now. So this is an actual image of real, honest to goodness atoms. This is an image taken with an incredibly expensive microscope. Hold on. There it is. So if you have a spare bedroom in your house, you can get one of these. This is called a transmission electron microscope. It's about $1 million, and it takes about 12 to 24 hours to prepare a sample just so you can look at it and see atoms. So you're going to run out and get one? Mm, okay. So these are actually gold atoms. This is an image of gold. I couldn't find any of copper atoms. But to point this out, just look at this. This scale is incredibly small. This scale means this bar in this image is 2 nanometers in length. That's 2 times 10 to the minus 9 meters. That's 2 billionths of a meter in length. Look at these atoms. What do you notice about them? Do you notice the patterns? Do you notice the rows of atoms up and down and across and left and right? There are rows of beautifully arranged atoms everywhere in the structure. And the thing is, almost every single material you've ever held that's a solid has atoms arranged like this. Now, this is a material with one type of atom. If you actually had a compound material, you'll see different types and different sizes of atoms in there. But the moral of the story is you can see atoms. They're incredibly ordered and arranged. And not only that, but the things we can't see that are in here, the things that we can't see are the bonds. Every single one of these atoms are stuck together with a bond. This is why solid materials don't fall apart, because all the atoms are bonded together. Now, a question that I'm going to kind of throw at you right now is, would you want to inhale this at once? Imagine if I could go back over to the penny for a second, and if I could actually count the number of copper atoms across. By the way, there's about 68 million, and there's about 5.5 million through the thickness. Would you want to inhale all the? Would you inhale a penny at one time? My kid brother actually inhaled a Cheerio when he was a kid, but it didn't end well. Let's just say that. Would you actually want to inhale all? If you could imagine taking all of these atoms, 68 million across, would you want to inhale that at one time? Well, probably not. Not a good plan because it's a solid material. We don't inhale solid materials very well. Okay? Well, you say maybe I could heat it up and boil it, or even better yet, make it into a gas. Could you make aluminum or gold into a gas? Yeah, but it'd be really hot and you'd burn your nose if you did. Okay, so suffice to say, we don't inhale solid materials like this. Now, we do have names for this. This material has a name. This specific shape of this beautiful arrangement of atoms is what we call a lattice. And maybe you have a lattice on your house to shield out nosy neighbors. Maybe you grow flowers on it. The more technical name for this type of arrangement, materials, solids that have this type of arrangement is what's called a network solid. All right, so there it is. Every single metal you've ever handled, silver, gold, aluminum, has atoms arranged exactly like this. Most ceramics, bricks, have atoms that are very similarly arranged. Oh, by the way, we talked about atoms, we talked about elements. Okay? We're getting to the other types of materials right now. Things that do not have atoms that are arranged like this. Okay? Um, Here's what we haven't talked about yet. These are gold atoms. We know that there's copper atoms in our penny here. Um, are there any other different types of atoms? Well, it turns out there's about 118 of them. Okay, I'm going to show you that right now. Okay, so what you're blah blah blah. What you're looking at right now is a table that we call the periodic table. Wait for it. The periodic table of elements that shows you every single different type of atom that we know of. Atoms from hydrogen to oxygen to iron to zinc to platinum to gold, mercury, thorium, uranium, helium. Every single thing listed on here is an atom, but individually they are called elements. This is how we differentiate them. If I go out in the parking lot right now, I see a whole bunch of cars, but this isn't a Ford dealer. They're not all Fords. There's all different types of cars out there. So to differentiate one car from another, I call it a Honda Civic, I call it a Volvo, I call it a Chevy. We do the same thing with atoms. Hydrogen, lithium are two different types of atoms. Individually, to differentiate them, we're called elements. Okay? So atoms and elements, we're good. Um, well, can atoms combine together? What do you think the answer to that question is? Absolutely. In order to form a compound, I just simply need two or more atoms stuck together. And I can make a compound like everyone's favorite, whoops, let's change the color. Everyone's favorite thing to put on a French fry, NaCl. This is a compound of two different types of atoms, sodium and chlorine. Apart, they're evil. Together, they're delicious. Um, Sodium chloride, take the smallest piece of table salt you can find, the smallest piece you can even see with your eyes, and guess what? The atoms in that table salt will be arranged exactly like this. Well, the only difference is, except having identical atoms, you'll see sodium, chlorine, sodium, chlorine, sodium, chlorine over and over and over again. So sodium chloride is a compound. You are exhaling carbon dioxide right now. I want to put a little star next to carbon dioxide. You may be drinking H2O, or you may be drinking some kind of flavored carbonated drink which has H2O in it. You may have used sandpaper or have gone to the beach and stepped in some SiO2, some sand, silicon dioxide. These are all compounds. They are one atom bonded to one or more. In this case, this is silicon bonded to two different oxygen atoms. So compounds are made of elements. Different types of elements, different types of atoms are called elements. All right, so we talked about atoms, we talked about elements, compounds, network solids. Let's finish up with molecules. Remember before when I asked you if you'd inhale a penny? And most of you said, what are you, nuts? You probably would not want to inhale a penny. Why? Well, it's a solid. It has billions and billions of atoms bonded together. Um, Probably not a good idea to inhale it. It may be stuck up in your nose for quite some time. So what do you inhale? It turns out you inhale molecules. Certain types of matter do not like to stick together to form really broad network solids like sodium chloride or iron or aluminum. These are all materials which form network solids. Materials like carbon dioxide or methane do not form huge interconnected network solids. Instead, they form things we call molecules. Now, a molecule is different from a network solid in this sense. And I need you to think about it in terms of, I want you to exhale right now. Just go ahead. Okay, every one of you has taken biology so far, right? I have to pause because I have to cough. Okay, every one of you has taken biology. And what do you do when you exhale? You exhale carbon dioxide. The thing is, do you like hack and spit and cough up a big lump of carbon dioxide? Do you hack and spit and cough up a lump of interconnected carbon dioxide atoms? Carbon, oxygen, carbon, oxygen, carbon, oxygen. Is this what we see on the street corners? Big gooey gobs of carbon dioxide that you've hacked up? Of course not. Because carbon dioxide does not exist as a network solid. It can if you get it cold enough, but it doesn't even like to stay that way. Carbon dioxide's a molecule. What does it mean? Well, I have literally a carbon atom. I just drew an oxygen atom. I have a carbon atom with two oxygen atoms stuck to it in a bond. And I'll change the color to represent the bond. There's the bond. And I'm even going to draw a little package around it. There it is, a little package around it. That's one carbon dioxide molecule. Wait for it. That's one carbon dioxide molecule. Is carbon dioxide a compound? Answer that. Let's see, a compound has to have one or more different types of atom bonded together. There it is. Oxygen and carbon. Yeah, carbon dioxide is a compound. Is carbon dioxide an atom? Well, it's not one atom. It's actually two different types of atoms. Is carbon dioxide an element? Well, it's up. So just got a text message. It's actually got two different elements in it. Is carbon dioxide a network solid? Nope, for the reasons I just talked about. So when you're exhaling carbon dioxide, what does it look like? Well, you got to breathe them out. You got to breathe out all the carbon dioxide molecules completely separately. So you're going to breathe out this carbon dioxide molecule, and then you're going to breathe out another one over here, and another one over here, and another carbon dioxide molecule over here. Okay, I just went and drew a bunch of circles around here. So when you exhale billions of completely unconnected carbon dioxide molecule. There's a molecule here, and a molecule there, and a molecule there, and a molecule there, and a molecule there. In fact, they're all completely not connected at all. There's absolutely no connection. There's no bond between those two carbon dioxide molecules. Do other materials behave the same way? Sure. Right now, there's water vapor in the air. You are breathing in uh, H2O as a molecule. Uh, if you go home and turn on the natural gas, you will be breathing in or burning individual molecules of methane. The point I'm trying to make is molecular structures do not form interconnected network solids. These are the things responsible for most of the gases that you observe. Um, can molecular materials eventually form solids? Sure. Things like butter, things like acetone, or that's a liquid. Acetone, nail polish remover. Butane is a great example. Butane is in a lighter. It hates to be a liquid. It wants to be a gas. It wants to be individual molecules. As soon as you push the lever on the lighter, you can actually watch the butane turn into a gas. Okay. All right. So I just want to recap quick. We talked about 5 basic forms of matter. Every single thing here has mass, takes up space. We talked about 2 really big different arrangements of matter. Things existing as network solids and things existing as molecules. And that wraps things up for today. Okay. Thank you for watching. Have a great day.